Alright, make sure you get these in the right order, because what happens usually with the reflection and a shift, if you don't put it in the right order, it'll shift the wrong way and reflect it the opposite you wanted it to go. So make sure order of operations prevails here. Okay. We have the squaring function, and this is probably the one you couldn't get, right? One with the 1/2 and the 2. This is your shrink and your stretch. This is the one we didn't hit yesterday. I need your conversations to stop. This outside of here is actually shrinking this. It changes the distance to 0. So if I did this, if I did 1, 2, 3, 4, and I plugged a 1 in here, 1 squared is 1 times 1/2. Normally your x squared would say 1. This is 1/2 x squared. So we're at 1/2. 2 squared is 4. Half of 4 is 2. 3 squared is 9. Half of 9 is 4.5. See it happening? It's shrinking the distance to half. It looks like a stretch because it looks like it's pulled up, like it's stretched out like this, but it's changing your distance to 0. So when you get here, it's this guy right here. It flattens it out. A stretch will pull it up this way, and we'll see that in the next one. And a shrink will stretch it out because it's lessening your distance to 0. So if this is your 1, 1, 1/2, see your distance to 0 is changing. So anything less than 1 is going to give you a shrink. I think you guys did these in geometry and algebra, did you? Yeah? Okay, now this, take this out of here, and you have the squaring function, then you're actually stretching it now. So if I did 4x squared, I would multiply this by 4. So it's increasing my distance from 0. This is giving me a stretch. And what happens to it is this guy. It pulls it up like this. It stretches it. So a lot of times kids get confused and they say this is a shrink, this is a stretch. Just the opposite. This is stretching my distance. This guy is shrinking my distance, flattening it out. Okay? That's the only part we didn't hit yesterday. And does that affect my domain or my range? No. No effect on my domain or my range. Number 4, same things work with a square root. Same things work with absolute value. Same things work with your cubes. So here's an absolute value. We start with your basic function. We shift down 1. Vertical shift down 1. This is the guy that's going to change your range. Your range is going to be now -1 to infinity. And then we did a vertical shift the opposite way, positive 3 units right. Good? All right. Now, you can do your transformations off of the graph, especially any of like your slides, off of a graph. So if I'm taking this function, whatever this happens to be, this black one right here is the function. And I'm just going to perform whatever they ask me to do. So it says take these points and shift them up to. What's going to change, the x or the y? Look up here. If I'm shifting this up to, what's going to change? The y. So every point is just going to move up to, up to, up to, up to. See it? You can take your original points and do this. +2, +2. That's another easy way to do it. Take your points and apply your rule. Some kids see it perfectly on the graph, others don't. I'm not a very good visual person, and it's tough being a math teacher and not being very visual, but I usually end up doing this. Okay, so all you had to do was do the plus 2. Now, they said take this guy and reflect it. Is it next to the x, the negative, or next to the y? So when y goes from negative to positive, where's my reflection? X-axis, good. So I'm reflecting on the x-axis. You can apply the rule, if you want to, over the x-axis, the x stays the same, the y negates. Or you can take this and reflect it over the x-axis. Here, this point is on the x-axis, it stays, this point comes down, this point comes down. You can do this off of the graph as well. And these are where you get your circles and everything from. You know, when you change your origins of your center of your circle, this is where the transformations come from. Kind of gives us a different look at that now. Another one, it's the black line, that's your function. You're going to take this, you're going to shift it 2 units to the right. So which value is going to change, your x or your y? Your x. So if you want, just take this and say add 2. On your graph, take this and go over 2, go over 2, go over 2. Okay. You shouldn't change the shape or the size of this because there's no dilation in here. Dilations will change the size and never the shape. So you should see exactly the same shape. This one said horizontal shift left 3. So I'm changing my x value horizontal, minus 3, minus 3. All the way down. Just take this, move it 3 units to the left, 3 units to the left, 3 units to the left. Is everybody okay with these? They're confusing when you first look at them, but they make total sense when you start to work with them. Okay, just looking at your graph, identifying your parent graph, finding the domain and range. Was this on your paper? No? Find the domain and range? No? Okay. So we started this with a squaring function. And what it did was, it took a vertical shift. Here's your graph. It started as a squaring function. It took a vertical shift down 1. I know it's 1 because this guy's -2, this guy's -2. There's your tick marks for 3. There's your tick mark down 1. So it took a vertical shift down 1. Can you make the equation? Okay. The domain stays the same. The range drops 1. Absolute value. Your parent function, your core graph, was your absolute value. It took a shift over. And if you can kind of see the tick marks, these were 2. So that's 2 that way. So it took 2 the opposite way. You got to give it the +2 inside. If it affects the x, it's inside the bracket. And no domain change for that. Here's your square root function. Looks like it went flipped over, so this is a reflection. You just got to be careful which way you're going. You reflected it first over the x-axis, so if you go over the x-axis, which one negates? The y. So therefore it's not near the x, it's outside of it. And then it took it and moved it up 1. Cubic functions are a little tougher to see. They don't really, they kind of flow a lot nicer. But this took this, it looks like it's going the opposite way. So this was a reflection first over the y-axis. So when you go over the y-axis, x negates. There's my -x. Once I negated it, it shifted it up 1. There's the shift. And with this one, it probably works the same way as the other reflection. Sketch the parent. Was everybody okay with these guys? Sketch the graph and the parent graph and describe your transformations. There's a reflection. if it's changing the y, the reflection over the x-axis, you have to be able to give me the transformations. This one is a reflection in the y. It ends up to be the same graph. It's the same exact graph, a reflection over the y for your parabola, because your symmetry is through your y-axis. And this had a negative. It doesn't matter if they put the negative out here, or on top, or on the bottom. It's still a reflection. And here's your reflection with your negative x. Positive to negative over the y, so it's reflecting here. It's a reflection either way, x or y.
Why is number 12 like, why is it a reflection over the y and not the x?
Because the negative sign is next to the x. So if you're going from a positive x to the negative x, it's a reflection over your y-axis. If the negative sign is next to the x, included in the parentheses, then it changes the value of x. X will go from positive to negative.
So my calculator's
It's like your calculator, that's why it's important to have those parentheses.
Wait, no, it
So
didn't.
why is the 11 going over the...
Wait, say that again?
Then why is the 11 going over the x? Like the negative sign is
This is going over the x, this is going over the y. Your reflection went negative x, pick a point, 2, 4. This point over here is negative 2, 4. See your negative? It's by your x. What's negative 2 squared? 4. So if you're moving from a positive to a negative, your reflection is over your y and your x. Remember, it's the opposite. It's kind of like your intercepts. So if you're going negative and positive x to negative x, your reflection in the y. This guy was not next to the x. This affects your y. So say I said absolute value of 4. This makes my x stay at 4, but now my y is at negative 4. So 4, negative 4. This gives me a reflection in the x-axis. My y is negated. It's got an opposite effect. If your y negates, that's why do it with your finger. You're reflected over the x. If your x negates, you're reflected over the y. And
so, if there was no parentheses on number 12, it would be over the x-axis.
it would be over the x-axis. Because watch, if I did this, and I squared this, I get negative 4. It makes a difference, just like with your calculators, when you use that parentheses or not. Okay, this one had a shrink. It's just gonna shrink your distance to 0. So instead of, like, if you plugged a number like 1, if I just did y equals x squared, x cubed, and I put a 1 in there, then it's a 1, 1. If I do this, I put a 1 in there, times this, it's a 1, 1, 4. See how it changed your distance from 0? So it gave us a shrink. If the factor you're working on is less than 1, if it's a fraction, it's between 0 and 1, you have a shrink. If it's greater than 1, you have a stretch. A negative does not come into play in there because a negative is a reflection. So you can't have a negative stretch. Like if it said this, if it said this, guys, you have two transformations in here. You have a reflection. If it reflects and changes the y from positive to negative, you have a reflection over your x-axis, and then you have the 1/4, which gives you a shrink. So you can never have a negative 1/4 shrink. It's a reflection and a shrink. Same thing if it's a whole number, a negative 2x, a negative 2x squared. It's not a negative 2 stretch. It's a reflection and a stretch. It's two transformations. You can't have a negative stretch or a negative shrink. So you've got a reflection and stretch. Do your stretch, then do your reflection, and that one doesn't matter which way you go with that. Do your reflection and then your stretch.
So it's 14.
A shrink. It's between 0 and 1. Whenever it's a fraction, you took part of your number. So you lessened the distance to 0. You shrunk it. it looks flatter,
Looks
but
like
it's a shrink. It has an opposite look to it. It looks like you did, because the other one, if I put a 4x cube, goes like this. That's a stretch. That's stretching the distance to 0. And you can always put these in your calculator. A nice way to do this is put your parent graph in your y1, then in your y2, put your new graph, and make this dark. So you'll see your parent graph go through, and then you'll see your transformed graph go through. Another way to look at it is look at the table. Look at the x's, and the x will stay the same. Look at the effect it has on the y. Did it multiply it? Did it make it smaller? Did it make it bigger? That's when you can tell if it's a shrink or a stretch. So your table will go like this. This is for the x cubed. This is for the 2x cubed. So if I have a 0, that's a 0. A 1 and a 2 gives me an 8. Whatever this is, a 2. Let's take that out of there. And then an 8. You'll be able to see. Where's my next one? An 8. Then you'll see it multiplied by 2. You'll see the stretch. You'll see the stretch in the y. The x, of course, is going to stay the same. That's why we call these non-rigid. The x doesn't change, just the y changes. Good? Today I was going to... So what's my parent graph? What's my core graph?
That's second.
No, my basic core graph that I do everything from.
X cubed.
X cubed. Simon, you with me? Parent graph. Let's just draw this guy out a little bit. It's a cubing function. What's the domain?
All three of them.
You know what? It's never going to change our domain or our range. So when you say, let's change this to a squaring function. Let's change this to, it's not going to change our domain and our range. So let's change this guy to a squaring function. Change this to say square. This way we affect our domain and our range. So our core graph is going to start with the squaring function. What's the domain on this guy?
All numbers.
What's the range? 0.
0,
Infinity. Good. Okay. So we're going to start with your basic squaring function. It's the first thing we're going to do to it. No. Move where?
For left side.
To the left 7. You have to follow order of operations. The easiest way to do this is take a value for x and plug it in and say, what would I do first? So say I picked x as 1. I'm going to do 1 plus 8. So therefore, I'm going to do the plus 7 first. You have to follow ordered operations. So we're going to move this to the left 7. Okay. This shifts me, and I want to keep track of my transformations. I have a horizontal shift, and you have to use the right words. God bless you. Left 7 units. Okay? What's the next thing I'm going to do? Kyle. Nope, not yet. X is 1. So the first thing I did was plug x in here. I added 7, squared it, came outside of my parentheses, and what am I going to do next? Multiply it. So it's going to multiply, so what is this going to give me? A stretch or a shrink? Shrink. It's less than 1, right? It's a fraction. Because it isn't a fraction smaller than what you start with. So it's a shrink. Guys, stay with me. 3/5, a vertical shrink. Is this gonna change my domain or my range? No. So a vertical shrink, because this is a fraction, it's less than 1, it's just gonna make my graph move out a little bit. I'm changing the distance from 0. Okay? Let's go with 3. Okay, what's the next thing I'm gonna do?
Go down.
Nope, not yet. I'm coming out of here. Order of operations. This is still one term. Negative. What does this negative force me to do? God bless you. Is this close to my x? No. Is it near my x? No. So it's affecting my y. When the y goes from positive to negative, where's my reflection? Over the x-axis. Good. Okay? So I'm taking my orange person here, and I'm reflecting this. Did this change my domain? Not my domain.
The range.
The range. So right now the range is what?
0 and
Negative infinity to 0. Very good, though. You had the right part of it. Okay, so the last thing I'm going to do, I completed this whole term now. I completed my term. Now I'm going to drop it 5. Vertical. A vertical shift down 5. I take this and I move this down 5. Did I change my domain? No. Did I change my range? So I took this and I subtracted 5. My new range is negative infinity to negative 5. This point here should be my vertex. Does anybody know what that vertex is? Negative 7, negative 5. Good. Now, try this last thing in your calculator and see if you get it. Look for the point negative 7, negative 5 as your vertex. So number 4, I can't fit it under here. Can I move this? I think I can move this. Number 4, vertical shift. Down 7. Just make my range go to here. And just made my range go to here. Go down 5.